West Coast Drive. You may have heard of this system. It is well known in the FRC community as one of the best drivetrain systems ever designed, even earning itself some fame as an easy, incredibly flexible, reliable, and simple to design drive system. Unfortunately, West Coast drivetrains can be difficult to assemble your first time, as there are not many instructions. Even experienced teams may decide that designing one is not worth the effort. YETI Robotics seeks to change that. In this guide, we will go over some of the advantages and disadvantages of West Coast Drive. We will then teach you how to design, order parts for, and construct one of these drivetrains from scratch. The West Coast Drive, or WCD for short, offers many advantages, such as being easily adjustable, easy to maintain and repair, and highly customizable. YETI Robotics uses this system because we can finish a drivetrain by day 3, and then immediately focus on other systems. This design is also lightweight and eliminates the need for an outer drive rail. In addition, it allows you to swap gear ratios with relative ease when compared to a standard kit tank drive. One huge advantage is that it does not typically need any fasteners that can come loose because it uses a riveted construction. However, this design exposes the wheels and increases the difficulty of mounting bumpers. Furthermore, it requires higher levels of precision during manufacturing, and while it can be partially holonomic, it cannot be fully holonomic. The design process of a West Coast drivetrain requires many steps. Firstly, the team must decide on the characteristics of the drivetrain and the type of wheels to be used. Second, the style and ratio of the gearboxes must be determined using JVN's mechanical design calculator. Third, the frame and drive rails must be designed in accordance with the strategy determined by the team and the size constraints of that year's game. Fourth, the belly pan must be designed to attach the frame and drive rails together. Fifth, the hardware and components for everything must be ordered. Finally, everything must be manufactured and assembled. During the first step of the design for West Coast Drive, the team needs to decide on what drivetrain characteristics are important to the strategy, such as pushing power versus top speed, small robot versus large, tall versus short, and etc. This will determine the main characteristics of the gearboxes and wheels. There are two main wheel layouts used in West Coast Drive. The first uses non-holonomic wheels on all of the axles, while the second uses omnidirectional wheels on the outermost 2 axles. Examples of non-holonomic wheels include hard slick rubber Coulson wheels, traction wheels which have a high traction tread on the circumference of the wheel, and wheels with pneumatic tires. It is highly recommended that you do not use Mecanum wheels on a West Coast drivetrain. Due to the design of Mecanum wheels, they will not work as intended with the gearbox. The number of wheels is also important. The most common West Coast drivetrains include 6 or 8 wheels, while some may include 10 or more, although it is uncommon. West Coast drives can also have multiple gearing ratios that shift like a car. The process YETI uses to design the frame is simple. We create a box in CAD that represents the frame perimeter shrunk a half an inch from the perimeter rules first. This will represent the allowable working area for the drive frame. Then we begin placing components on the system. It is crucial to determine the placement of gearboxes prior to construction of the rest of the drivetrain. This involves determining whether the gearboxes must be placed behind the center wheels or behind other wheels in the front or rear of the robot. The gearbox can serve as a counterweight to any heavy components of the robot on the opposite side of the drivetrain. Next, the physical parts must be placed in CAD and clearances to the ground and center of gravity must be checked to ensure that the gearboxes are in acceptable places on the robot. Once the drive rails have been designed, place the gearboxes, the battery, and all VexPro components onto the drive rails. This includes the mounting blocks, which hold the axles onto the drive rails, and the tensioning cams, which tighten the mounting blocks in place. And then lastly, the wheels to make sure that they all line up and that the frame will not bottom out on any field elements. The drive rails are the rectangular metal tubing that hold the gearboxes to the drivetrain. These must be very precisely designed and must include a dropped center on the wheels if not using holonomic wheels. A drop center is where the center wheel, or center 2 wheels if designing an 8-wheel West Coast Drive, is lower than the other wheels in the drivetrain, usually by 1/8 of an inch. This is done to prevent scrubbing of the outer wheels, a problem that occurs when there is no drop center, and all wheels drag against the ground as the robot turns. This could cause several things. The tread would start to wear down, the robot might wobble, and the robot may not turn properly. The motors may overheat, and the gearboxes might undergo serious strain. Next, the belly pan must be designed to hold together all the drive rails. It is recommended to pocket this plate to reduce weight, but still strong enough to ensure that the frame does not flex. It may also hold the electrical components of the robot. If this is an issue, buying expanded aluminum sheet would also suffice. Finally, all the components must be ordered. This includes the gearboxes, motors, tubing for the drive rails, and the belly pan, which may have to be machined using a CNC router, laser cutter, water jet machine, or other tool. Depending on which gearbox you selected, it must be ordered from a different company. VexPro and West Coast Products both have the West Coast Products dual-speed and single-speed gearboxes, and the VexPro 2 and 3 sim ball-shifting gearboxes, as well as any VexPro components required. The motors can also be ordered from these two vendors, but the metal tubing for the drive rails and the sheet metal belly pan can be acquired from several different sources. Creating this guide for the community will hopefully spread the idea that it is easy to make a West Coast drive, and that it is obtainable for many teams. Check out the next few videos in this series to learn how to create one step by step. If you have watched this series and have any suggestions, leave us a comment below.